going to look at a couple of examples that illustrate cluster and stratified and simple random samples. In this example, it says a school librarian wants to know the average number of pages in all the books in the library. The library has 20,000 books arranged by type, fiction, biography, history, and so on, in shelves that hold about 50 books each. Explain how to select a simple random sample of 500 books. Well, this would be easy to do, but a pain in the neck to implement. So what would you do? Number the books 1 to 20,000. Okay, so I'm going to use a random number generator, so something like use your calculator to randomly pick 500 different numbers between 1 and 20,000. And then you would have to go all over the library finding those 500 numbered books and count all the pages in them. So that would be a pain in the neck. Count all the pages in those 500 books. Now, of course, that part is going to be the same for every one of them. Counting all the pages in 500 books is going to be difficult no matter what method you use, but having to number all the books and find all the books is going to be a real pain in the neck. Okay, a stratified sample. In a stratified sample, probably you would stratify by genre. I can't think of any other way to stratify that makes any sense. This would be based on the assumption that maybe a fiction, biography, history, children's books, etc. would on average have different numbers of pages in general. Okay, so maybe we would divide it into a certain number of genres. I don't know how many different genres there would be. Maybe reference books would be another genre, so forth. And then you would randomly select within each genre. I'm not sure how many you would randomly select because you want 500 in all, but randomly select books. You'd have to number them first within each genre. And then once you had all of the books, then you would count all their pages and average them and so forth, the same thing. It would have to be, your choice of strata has to be based on how many books or how many pages the books have. If it's not based on that, then there's no sense in stratifying. Once again, though, you're still having a lot of books scattered all over the library, and it still seems like it would be kind of a pain to do. Okay, a cluster sample. Now remember, a cluster has to be representative of all of the books. Okay, so it has to have a little of everything in it. We honestly talked about this and couldn't figure out a way to do this, because if you randomly select an entire shelf, that doesn't necessarily represent all the books in the library in a shelf. That's probably all the books in a particular genre. Might be a representative of the books in a particular genre, because probably all the children's books are on a shelf together, and all the biography on a shelf together, all the history or the fiction are on shelves together. So finding a cluster doesn't seem like it's very practical. However, we did think about something called a multi-stage sample. In a multi-stage sample, you have two different methods. You do one at a time. So first we would say stratify by genre, and then randomly choose one or more shelves in each genre. I'm having trouble with genre here. And then use the entire shelf as the sample. Now this is a multi-stage in that first you're stratifying, but the shelf is a cluster. So basically you're randomly selecting a cluster, which is the entire shelf, within a genre, which is the stratum. So this seems to me the most sensible way to do this is because all the books would be together on the shelf, but the shelf would represent then this whole entire stratum, which would be a genre. none of these methods are terribly great because you're still having to count all the pages in 500 books, but I think that multi-stage method is probably the best method for this particular example. I think we talked about the drawbacks already, so I'm not going to go over that. Now I want to look at another example that maybe more clearly illustrates the difference between stratifying and cluster. So let me go on to the next page. Okay, so here we have, I'm going to make this a little bit bigger here. This is Michigan Stadium, and it says it's seats over 100,000 fans for a football game. The University of Michigan Athletic Department plans to conduct a survey about concessions that are sold during games. Tickets are most expensive for seats on the sidelines. The cheapest seats are in the end zones, where one of the authors sat as a student. A map of the stadium is shown. So the questions, which are kind of cut off here, first of all, it says these are the most expensive seats, the orange ones, the cheapest are the blue, and then the yellow ones are in between. So if I wanted to do a stratified method, then I would randomly select one or more sections of each color. Okay, so the color would be my stratum. So maybe I would randomly select a blue section, a yellow section, and an orange section. Or maybe if I wanted to randomly, since there are more blue than yellow, maybe randomly select 2 blue, 1 yellow, and 2 orange, or something like that. And then within each of those, within each of the stratum then, well, actually that's multi-stage because I'm randomly selecting a cluster first. So let me back up and do that one again. So what the stratum would be, the blue, the orange, or the yellow. So what I would do is among all of the blue students, I would randomly select a certain number of that are in the blue seats, not the blue students. I'd randomly select a certain number of people in the blue seats and the yellow seats and the orange seats, and then I would go find them and interview them. Now that would be kind of a pain because they could potentially be sitting anywhere in the blue section, anywhere in the yellow section, anywhere in the orange section. So I would have to go find a lot of individual students. So that would be kind of a difficult thing to do. But it would give a representative sample from each of the 3 groups. So a cluster sample actually might work better. In a cluster sample, I want to have a cluster, randomly select a group that would have orange, yellow, and blue seats in it. So notice that there's a kind of a symmetry to the stadium. So maybe I would only need to look at 1/4 of the stadium. Okay, so 1/4 of the stadium that would have some orange, some yellow, and some blue in it. And then I notice that people are in rows. So maybe I would randomly select 1 or 2 rows of students or people, and I would just go across that row 1/4 of the way around, and it could be any of the fourths that it would pick. So I'd randomly select one of the rows and go around and interview everybody in a row. And that would be a whole lot easier to do. That would be a cluster. And of course we could still combine methods. I could randomly select a section and then randomly select a row within the section. So that would be like a stratum and a cluster. So there's lots of ways to do this, but I just want you to remember that stratum means everybody in the group is the same. Everybody's in the yellow, everybody's in the orange, or everybody's in the blue within the strata, and then you randomly select within that group. A cluster would be, I would have a little of everything in it, and I would randomly select a group that had a little of everything in it, like a row. So that's a pretty good illustration of the difference between a stratified sample and a cluster sample. So make sure you know the difference and can explain them and the advantages and disadvantages. I guess I probably do need to say that a little bit more. The advantage of a stratified sample is that it does reduce the variability in your results. We saw that in the cornfield example. The cluster sample does not reduce any variability because you still have a little of everything in your sample. But it is more convenient and easier to implement. Now, it is not a convenient sample because in a convenient sample there is no randomization done at all. We are still randomly selecting the row that we sample, but it makes it more convenient to actually implement the procedure. So that's what's convenient about it.